Hello, everyone. It's Kateřina Peková again. I'm Tech Community Manager here at STRV, and I would like to welcome you all here at our 15th online event in these quite interesting times. So I'm really happy that there is such a great show up, and I hope that you will all enjoy the talk without any major technical issues. So firstly, let me introduce just some basic rules so your experience is as lifelike as possible. You have a number of possibilities how you can interact with another attendees or with our speaker or another panelists. So first option is that you can raise your hand. This will be our priority. So every time anyone will raise their hand, our moderator will step in, call you up, unmute you, and you can ask the speaker your question directly. You can also post your question to the Q&A section. We will get to that after the talk. And also don't hesitate to use chat. You can chat with other attendees or also with with us as a panelists. So I just want to let you know that you have an option if you want to post your message to attendees or attendees and panelists. So always make sure that you are sending the message to the right person. Okay, so that's basically it. Now I would like just to do a quick introduction. First, let me introduce our speaker, Sebastian Leon, and along with him, Jan Kaltoon, our iOS platform lead, whom I would like to give a word right now. So thank you guys and enjoy.
Hello, everyone. Thank you for coming in such numbers. That makes us really, really quite happy. And before I keep talking, Katka, please run the poll. We have prepared a little bit of question, well, actually just one, with two possible answers to find out what you know about instruments. Well, as already mentioned, I'm Jan Kaltoon, the iOS platform lead here at STRV, and I'll be your MC today, which basically means I will now introduce Sebastian, and then I will ask him all the questions that you may post in the Q&A section or in the chat right after he finishes his talk. Sebastian Leon is an awesome iOS engineer here at STRV, coming all the way from Colombia. So we have something really quite awesome here today, and something that you may not see in many other places. So without further ado, by seeing that about 50% of the people have worked with instruments and 50% have not, I will leave it to Sebastian, and please take it away.
Thank you, Hansa. Thank you, Kate. And thank you, everyone, for being here and taking the time to share with us. So without further ado, I'm just going to share my screen, and I'm going to start with this presentation. Okay, so half of the people here have actually worked with instruments and have done. So I'm going to try to give you like I wouldn't say a deep dive, but a dive into the instruments and what is it and why we use it, along with a demo. Okay, so let's go. So instruments, rather than being just an instrument, is a collection of instruments, right? So every icon that you see here is actually an instrument, and it fulfills a certain purpose, right? Why we do this? This is because we want to get more insights about our app. So we'll be using this for profiling and debugging our apps, right? And we do this because we want to do not good, but perfect and flawless applications. So this is like a set of tools that is ready for you to use, and it comes with Xcode. Okay, so the goal here is boost the performance of your apps, or fix a memory problem, or improve the battery life of your app, right? So this is what we're aiming for, and this is what we want to do. I'm going to show you what we can do to find the bottlenecks of your app so it can be better. Okay, and every instrument, not all of them, but but some of the instruments work by taking snapshots of your app, right? And this works at constant intervals depending on the instrument, right? If you have set everything correctly, it will show you the methods your app is calling, and it will give you an average of how much time was spent in it. Okay, so this is basically what it does. Now, under the hood, this uses a dtrace tool, which is a command line tool that I will talk a little bit more after. But well, it is important to define a workflow when you're trying to work with instruments, right? Because you just don't go and use instrument just because, right? You have to collect data, right? And when you have the data, you might think, okay, my app is not working well, or it could work better, right? After that, you start formulating a hypothesis of what the problem might be, and after that, you want to do changes. But I must warn you, you should probably be doing small changes. So my recommendation here is aim small, make the change, then verify that it's working okay, and then repeat this process whenever you feel like it's convenient, right? The rule of thumb I manage is every time I finish a feature, I try to go to instruments and check how my application is doing, right? If it's working smooth enough, if I'm not leaking memory, and so forth and so on. So before jumping into this, today I will be showing you the time profiler and the memory debugging, which the allocations instruments and the leaks instrument is part of. Okay. Now the time profiling, or the time profiler, as I mentioned before, uses a dtrace tool. A dtrace tool is a command line tool that, well, if you guys are interested, you can create your own tools. And what this actually does is it will insert into your app at runtime, and it will give you these insights that we're looking for. It will start creating trees and subtrees of tracing and tracing all the methods your app is calling. Something important to mention here is the instruments will not give you the exact duration of each method, the exact duration of the method that was called inside your app, but rather it will give you the count of the numbers of these methods that see in the sample. I will show you a little about this in the demo. Okay. So for the demo, I have prepared a little project which is about animes quotes. Okay, because I like animes, so I wanted to prepare something. So I'm just gonna go ahead and run the project, and well, you will see that it stutters a little. And this is a pretty basic app. It just have an image, a label, and if you tap on it, you will see a detail with basically the same information, right? So a disclaimer in here, this is not production ready code, okay? So don't judge me. This is only for demonstrational purposes. Okay, so now for jumping into the instruments, you can actually come here and product profile. You can actually hit Command I, or you can long press this button and tap on profile. So I'm just gonna go ahead and tap Command I to launch the instruments tool. Okay, so I guess it should be here somewhere. There it is. Okay, so this is what I showed you before in the image. Every one of this is an instrument, and I'm just gonna come here and choose the time profiler. Why the time profiler? I think this is your best friend. This is the thing. This is the instrument that you want to use the most because it will show you the bottlenecks of your app, right? While, for example, the allocations instrument or the leaks instrument will show you only the memory footprint of your app, but that's not visible for the user, right? So to show you a little bit about the instruments, or so you guys get to know it, this is the record button. This is what you want to use when you want to start a new profiling session. This in here is the trace section. In here for the instruments, you will see, for example, the heaviest stack trace, and in here you will see the information about this profiling session. This will show you, for example, the device you are running or the iOS version. In here you can see the information or the traces separated by threads, the CPUs. In here you can, for example, add another instrument on top of this one. So you can have more instruments inside one profiling session, and this is the timeline. So okay, so I'm just gonna go ahead and record this profile, and I'm gonna start using the app like I would normally do, right? And I can see that this is very slow because well, I'm loading like a lot of images, right? But it's not smooth at all. So I want to collect the data, right? This is what I'm doing right now. And once I feel that I have enough information, I'm just gonna come here and pause or stop this particular profiling session, right? So I'm just gonna come here and check my main thread. Why the main thread? Because this is what can actually block the user, right? So it is important if we want to boost the performance, we might want to look the main thread most of the times, right? So I can see in here in the main thread many spikes. So I see here 95%, 100%, 100% again. So this is interesting. So I'm just gonna tap and drag in here so I can take a particular look at this sample. And for example, in here in the country, you will see this separated by thread. This is very useful because it will show you the threads discriminated. You can also hide the system libraries if you want. You can invert the country, separate by state. But I'm just for this example, I'm just gonna hide the system libraries, and I'm gonna start digging here. By the way, you can actually option click in here so you can see the full trace. But you guys remember I actually hide the system libraries, and in this particular scenario is not good for my trace because I can see nothing in here. This is showing me that actually the data source is what is taking most of the time, right? In the cell configuration, that is not accurate. You can also see in here the heaviest stack trace. This is going to be useful. You guys might want to keep this in mind because, for example, I'm going to unhide the system libraries, and I'm going to check again the main thread. Okay, so I'm just gonna try to follow along what is going on. And by the way, if you guys see these icons and wonder what they are, for example, this is our app. This is Coco, right? This is Core Graphics, and so on and so forth. So whenever you are doing a trace, you kind of want to start digging, right? So this is what I did with option click. This will stop when it finds the heaviest trace inside this tree, right? And you also want to pay attention to this, but most importantly to this, because this is the way, this is the percentage that the method took to complete. And this will actually show you the information discriminator, right? So if I come here and I see this, this might be a little overwhelming because all I can see here is CF run, loop run, and a bunch of system calls that, let's be honest, it might be overwhelming. But if, for example, I start coming down here, I start to see, for example, a CA transaction, but I don't know what is causing this, right? And I have another one here, and I can see, for example, if I close this, I can see that the total amount of time was 1 second, 1.21 seconds, and this specific part is taking 1.6 seconds, 1.06 seconds. So it must be here. There's something that I must be doing in here that is wrong. Okay, so I'm just going to step on here, and I'm gonna check the stack trace. So the same information that you are seeing here, you will see it here. So as I know, because of previous knowledge, that decoding images is an expensive process, I know that this is what is wrong with my app, the Apple JPEG decode image, right? So, so if you think about it and you form a hypothesis, what you're doing in here is decoding a bunch of images, right? They might be heavy images, but the process of decoding is heavy itself. Why? You might not notice this, but for example, whenever you assign an image to an image view, whenever you assign the image property to the image view, you are having a co-animation implicit transaction, right? And after when that happens, you are actually copying the image, decompressing the image, then rendering the image, and then actually, showing the image, right? So this is expensive. And if we look in here, all this process is being done onto the main thread. So we want to avoid that, okay? So I'm just gonna come here into my cell. This is the quote collection cell, which is this one. And I'm gonna check for my image. I know I only have one image inside this cell, so the image and the label. So I'm just gonna check for my image to see what is going on. So I can see here I'm preparing for reuse. I'm adding the image to the subview, and then I'm adding constraints, and then in here I'm setting the image. So I'm just going inside to this method and check what is going on, right? So I'm just getting the image, and as far as I can see here, this could be like a PNG or a JPEG, and this is all that is giving me an image. And this is the process that I was describing before, right? By simply adding this image to the UI image view image property. This process is expensive, but you may not notice this because it's for free, right? So we want to go ahead and fix this. So what I'm going to do is I'm going to comment this for future reference for you guys. And now for the sake of this tutorial, I'm just going to copy what I think the answer is. Now, if I know that I have many images and these images are not changing, it might be good to cache these images, right? So that's the first thing I'm going to do. I'm just going to create a very basic cache into my inside my UI image view extension. And again, this is not production ready code. This is demonstrational purpose code, right? So after that, what you might want to do is actually decode your image. You want to decode your image yourself instead of delegating this to the to the system, right? And now it would be good if all this work is outside of the main thread. So I'm going to replace my set image method with a method with the same signature, but that runs on a different thread. This is a thread with a pretty high priority, right? So all I'm going to do is send this to a background thread, then get my image as I was doing before, decode the image with the new method. This method will take care of checking if I have this image in cache or not, and then decode the image. And after that, I will switch to my main thread and assign the image again, my decoded image. Okay, so all that I did was to change my UI image view extension. So remember, aim small. Now I'm just gonna command I to launch the instruments again and check with a new profiling session, right? So this will launch my application, and I'm gonna start using my app. And then once I've done this, I can just come here and pause again, and I'm gonna repeat the same process as last time, and I'm gonna check my main thread again. Now that I can see that the levels of the spikes are 90% less, I'm happy with this profiling session. Of course, we can go on and on with this, or we can find many other improvements inside our app. But for now, I think this is pretty good. Okay, so that is for the time profiler. You can actually do more things with this. For example, checking your lunch time or any other possible bottlenecks inside your app. But as far as this presentation goes, that's it with the time profiler. If you have questions, I'll be happy to answer them later in the Q&A session. Okay, so I'm just gonna jump back to the presentation, and I'm gonna start with the memory debugging. Okay, now all that it does is checking the memory footprint of your app, right? And this is, I said before that the time profiler is your best friend because you want to spend more of the time in the time profiler, right? Because you want to check what is slowing down your app. But this is also important. It's not super mandatory, but it's good, right? You have a few tools at your disposal in order to check the memory footprint of your app. for example, generational analysis, which is when you, for example, have a starting point in your app, and then you, for example, push a view controller on top of that one, and then pop it back again. So you can check the memory. Ideally, the memory levels should return back to normal. You also have the allocations instrument, the leaks instrument, the memory graph debugger, which I'm not going to be covering here, but it's super useful. Most trivial one, the init function that you can call inside your classes just to have an overview of what's going on with your app. Okay, but talking about ARC, I'm pretty sure that many of you or all of you know what ARC is, but all that is a tool, right? It comes with Swift, and it helps you track and manage your memory app. You get this behavior for free, and when we say that this is managing your memory usage, is that it helps us to allocate memory whenever we need to, and it helps us to free this memory when it's no longer needed, okay? And it does this by keeping a strong reference between the instances and variables, properties, or constants, right? So whenever you assign a class to a variable, for example, you have a strong reference, right? We can avoid having extra references by using a weak or an own, which I'm pretty sure all of you guys know about this. Okay, so moving on, we have to help ARC by not creating leaks or retain cycles, right? So we have to help ARC sometimes because we can introduce this kind of things inside our code without realizing. And I'm going to show you two examples about this, which might seem trivial, or that you can actually introduce without even noticing. So we have to take care of leaks, and a leak is, for example, memory that you cannot recover once it's done, it's done. I mean, it's an orphan. You cannot get it back. So, for example, if your class has a reference to an object, and this is a strong reference, and you deallocate this this first class or this first controller, it cannot be recovered again because it's orphan, it has no reference, right? And then you have also retained cycles, which is when you hold strong references between two or more objects, right, to each other, so they are pointing to themselves. So I'm just gonna go ahead and jump into the Xcode again. I'm gonna show you, or in order to do this, I'm gonna switch the branch. Just give me a second. And we should be good. Okay, so in order to, I'm gonna repeat the same process. So I'm just gonna hit Command I to launch the instruments. And then I'm gonna choose the allocations instruments first. I forgot to close this one. So I'm just gonna close it and hit Command I again. So I'm gonna choose the allocations instrument this time. And I'm sorry, I think I forgot to show you this particular slide. I'm so sorry. Because all I wanted to say is that the allocations tracks all of your memory and not only the leaking memory. So this is the difference between having allocations and having instrument, right? The allocations cannot detect leak leaks, and it will show you all the memory your app is consuming. Okay, so sorry for that. I back again into the instruments. I'm going to hit the record button. I'm gonna see my app in here. I'm just gonna start to use it. And by the way, if you see this app stuttering again, it's because I didn't commit the changes that we did before. So I'm just gonna come here to this view controller, and maybe this one is Haiku. This is pretty good if you guys want to watch it. This one's really good as well. Okay, so once you have used your app a little bit, you can start checking your memory with the allocations instrument, right? So as I said before, this changes between instruments, and this will change as well. And this, all that this is giving you is a full picture of all of the memory your app is using. Now, if we take a look in here, this is kind of generational analysis, and this is you can actually do it from here with the mark generation option, but I'm just not gonna do that. So you can, if you see here, this is how our app starts. Then it starts going a little bit higher and higher and higher and higher, and it never gets back, right? So this is something that we might want to take care of. And I said might because we have a lot of images, right? And those images should be in here. And I know that these images are pretty heavy, so this must be it. But whenever we go to a detailed view control and then come back, some of this memory should be deallocated, but this is not what is happening, right? So you got the full picture of your app in here. You can see the call trees, for example. You can start digging in here or here, but I wouldn't recommend doing this at first because it might be overwhelming. I would rather much to do a different analysis. For example, I know that I have that when I go to my view controller, to my detail view controller, my memory should increase, right? And when I get back, my memory should decrease. But this is not happening. For example, you are not seeing this in here. Sorry, I'm not debugging, but this here are the debug gauges that might be useful. So I'm just gonna check instead for my detail view controller, and I can just come here and check well, the name for detail view controller and get back in here, and I can filter here, for example. And if, as I'm here on the main tree, I'm not gonna see much, right? This is CF run loop again. So you can come here to, sorry, the allocation list, and we can see that by filtering by our quote detail view controller, we can see it in here. We have 5 of this. We shouldn't have any of this, right? We can also, sorry, we can also come here and check the statistics and see that again, we have our quote detail view controller, and we have 4 of this, but we shouldn't have any of this, right? So my problem should be in here, right? So what I can do is simply come here to my quote detail view controller and check what is going on, right? So I conveniently add this in here. So I'm just going to show you what I would do if I have this photo manager, which is handling the images, right? Because when you go to the detail, I'm just going to stop this, sorry. Because when you go to the detail, you get this image somehow, right? So I can see here that my photo manager is taking care of this, right? And I see that it has a delegate, right? So I'm just gonna check my photo manager, and I can see here, well, first of all, this is a class, and I have a delegate. So I'm getting the image, and I'm sending the image back with this method. And I can check who is calling, who is actually using this method, and is my code detail view controller, right? Now, what I would do, for example, to solve this problem is, I also know that I have a strong reference in here, right, between my photo manager and my quote detail view controller. So what you can do is actually make it weak. So you're breaking the reference between this and the code detail view controller just by adding this weak reference. Okay, so remember, aim small. I'm just gonna hit Command I again to run it back again, and hit the record button and start doing what I did before. And I can see, if you guys take a look in here, you can see your view controller appearing and then disappearing. Okay, so we know we did something good. So of course, our memory footprint is very high because we have all these images. But once, I don't know if you guys can see here, it's very subtle. But when I pop this back, this memory is decreasing. So that is good in my opinion. Now I'm just going to jump ahead to the last instrument that I will be showing today, and this is the leaks instrument. Very, very similar to the allocations instrument, but it will only detect leaked objects. Sorry, it will only detect leaked objects. Okay, it will check the memory, it will detect the leaked objects. This one is a little bit different because it will be a snapshot in your app every 10 seconds. Okay, this is the default. You can change it if you want it, but I think that 10 seconds is pretty okay. So what I'm going to do is I'm going to jump right back into Xcode, but I'm going to change my branch again. Okay, so please bear with me. Give me just a second. I have my example ready. I'm just gonna, oh, sorry. Okay, just gonna come and build. Just gonna come and build. Give me a second. There's something happening in here. Okay, I'm just gonna quit Xcode and open it back again. Just gonna close this one too. Where's Xcode? Okay, sorry about that. I should be in the branch that I want, but I'm not. Give me a second. There's something going on with my Xcode. Just a second, please. You can tell a joke if you want, Honsa Kaltum, please.
A joke, you say? I'm always ready to say a joke.
If you have one.
Yeah, I do. But I will need Katka to reappear so that I have a victim for my horrible dead joke.
I'm ready.
Okay, Katka. Can you please tell me the answer to the following question? What did one ocean say to the other?
Hello.
Nothing. They just waved.
Okay.
Yeah, I know. My jokes are really bad. But it should buy Sebastian some time to figure out the branch issues.
It's not actually the branch, is just that my Xcode is not letting me run it for some reason. Not letting me compile.
Not even if you press play? Is it misbehaving?
Yeah, look, it doesn't allow me to play or pause or do anything.
Interesting. There's always something new with Xcode each time.
Let me check my master again.
You know, you can always do the classical shtick and clean the project. That could help.
Yeah, not helping right now.
Not even Command-Shift-K?
Nothing. Just a second, please.
That looks promising. Oh, we have the play button.
Okay, but this is a different branch.
So maybe try closing Xcode and switching branch and then going back. Maybe it's confusing it.
Yeah, that's what I'm going to do. Sorry about this, guys.
Don't worry. This is a real life example of the fact that Xcode hates everyone sometimes.
Exactly, and I'm ready for another joke if you want, Hansa.
Oh my, this is straining my joke-telling abilities. I mean, I do have a baby, but I'm not sure if I'm ready for a series of jokes. But I may be. But I'd like to help Sebastian with this, but really the play button is not appearing, which is hilariously weird.
Yeah, I really don't know what's going on now.
I can tell everyone in the audience that we have practiced this and it worked perfectly fine. There was no issues. So let's see. This doesn't seem to be a problem of the code itself. It's just Xcode. Maybe have you switched the branch after switching? Switched the branch after closing Xcode? You'd have, right?
Yeah, I did.
So let's try cleaning the project once more.
Okay.
I believe in cleaning. My wife would be very happy to hear me say that.
So we got a one note on our YouTube stream that seems like your project.
Oh shit, there's no scheme. Oh, that's
it's like there's no scheme. This is weird.
Interesting. I didn't notice. Well, we'll need to create a new scheme.
I have
Well,
no
you have
target.
even no target. Wow. Can you go to the project settings?
like the root?
Yeah, the
No.
project setting is in XCode. But I think that the easiest may be to just switch to the previous branch that actually has a target and a scheme, and then just comment out the example that you're currently in, then uncomment the ones that you need. That would be the fastest way of solving this, because creating a scheme and a target live, that is a horrible ordeal. Right, because you have all these mark example comments everywhere, so you can just comment out what you don't need and comment in what you actually need.
Yeah, but
I can maybe help you a little bit with that, I believe, because I actually do have the example number 3 in my version of the code that you sent me. So if I send it to you via Slack, we have a project that I know works for sure. How about that?
yeah, sure.
Okay, let me do that. I think that this is showing that not everything goes perfectly each time. Quite nicely. Where is it? Okay. So yeah, here we go. So Kate, while I'm working, and you are ready, you can say a joke.
Oh no, I have no jokes.
But Katka can.
Maybe
Okay.
if someone has any question.
Yeah, we do have a question. Maybe we can answer those right now. So Kuilai is asking whether he is also able to use instruments on a plugged-in device.
On a what?
On a plugged-in device, the device that is plugged into your computer, like over cable.
You mean like a real device?
Yep.
Oh yeah, well, I forgot to mention this, but well, this is a good question. You should actually always try to do it on a real device, right? For example, in here, I'm running iPhone 8, and the target of my project is iOS 14, right? So this one right here, the iPhone 8 is the lowest one for iOS 14, right? It has the slowest processor of all. So this is why I'm using iPhone 8. And I'm using the simulator in here because just for demonstrational purposes, right? But in real life, I would be using a real device because it will tell me the truth, right? It's the device. I mean, it's the real deal. In here, you have overhead, right? So yeah.
Thank you. Meanwhile, I sent you the project, so you can open it over Slack, and everything will be perfect and beautiful, and unicorns and rainbows and stuff like that.
Let's see. By the way, I'm so sorry about this. Let's see what we have in here.
Then, while you're working, there's another question from Kubilai. I will let you work on opening the project and answer this one. So he is asking, when looking for memory leaks, is it better to just go ahead and use leaks instruments, or could there be some leaks that aren't being detected by leaks and we are better off using allocations instead? This is an excellent question, and you may actually find out that many of the leaks that we typically call leaks when we look at the code are actually not detected by the leaks instrument. As Sebastian mentioned, the leaks instrument will only detect the leaks that are an actual memory leak, which means it is basically two objects pointing strongly to one another and this cycle being orphaned, so nothing is pointing to it. So for instance, in an example where you have two objects pointing to each other strongly, you basically have something pointing to them, the leaks instrument will not detect those as a leak. So I think that you should use both. The leaks instrument will help you to find out the obvious, like real deal leaks, but allocations instrument will help you figure out what's going on with your memory in general, and whether something is not being released, but maybe because only but maybe not detected because something is still pointing to it. I hope that makes sense.
Yeah, and this is something that I wanted to discuss, right? And this is why I put, for example, in this slide, that it only look for leaked objects, the leak instrument. So you gotta take care of it when you differentiate these two, right? Because as Hansa mentioned, there are orphans, right? You cannot reclaim it, and then you can also have retained side, right? So you gotta take care when distinguishing those.
Also, in a private message, we're getting another from Gatka. I mean, we're getting another question, probably from YouTube, which is, do you have instruments debugging as part of the development process, or do you do instrument debugging only when the problem arises? Do you recommend using the simulator or a physical device with instruments? Why? So I think that the physical versus simulator question was already answered. And I believe that the difference between instruments being used as a part of the development process or only when the problem arises kind of depends on the person, but I would probably suggest to integrating them in the development process, at least check them from time to time. But Sebastian can say more about that.
Yeah, for example, me, what I actually do is every time I finish a feature, I try to run the instruments again, right? So this is my rule of thumb. This is something that works for me, but this is not for everyone, right? But something that wouldn't make sense is to run instruments every single day, because this is not the way you do it, right? You might want to, for example, go ahead and put the init method inside your classes, for example, in your view controllers or your view models or your coordinators, just to check if that memory, for example, is being deallocated, right? But for example, when it comes to performance, you might want to run the profiler every now and then, right?
Right. We have one last message that is a joke, but before I read it, I will ask you, how are we doing with the project?
I'm fixing something in here.
Okay. For that case, I have prepared this joke by Martin Vidovic, who is saying, how many software engineers does it take to change a light bulb? And the answer is 0, because it's obviously a hardware issue. That's a good one. I should probably say it, tell it at the next iOS meeting that we have here at STRV.
So you're going to steal this joke?
Yeah, probably.
So if there's space for that, we have 2 more questions from YouTube.
Mm-hmm.
Okay.
Please ask away.
Is there a way to measure my big O complexity with instruments?
Well, you can with the time profiler, you can find the methods that are taking the most time, right? So that is a way to do it, but I don't think you can check the complexity per se, if that makes sense.
Yeah, I don't think that's possible either.
I mean, you can find the possible slowdowns of your app, right? But it won't tell you the complexity.
There's one more question that is asking whether there is a way to save those profile sessions for comparison.
Come again, please.
There's a question whether you can actually save those profiling sessions, the result of the profiling session, for later comparison. So if you can export the data.
Yeah, for sure. You can save it. I mean, that's actually one way to do it, right? Because you want to compare this with you want to compare this data with the new data, right? So for example, I didn't have the time to show you in here, for example, how you can improve your app launch process, but that would be like a pretty nifty way, or a pretty good example of when you can take advantage of this, right? You can download this and then check it, or you can just run you can just create your own document and check whatever you're interested into. Me, for example, I have a spreadsheet apart for checking the launch time from when it's warm and when it's a cold launch, right? If you guys know what I mean by that. So I've just actually take the time that it takes, the pre-main time. So all the time that it takes my application before it actually reaches the main method, and I try to improve that time, right? And I do that by, for example, making my libraries, instead of dynamic, I make them static. So that is one way to do it. Okay, I think I'm back with this.
Excellent. So let's continue.
Okay, so I'm just gonna go ahead and run this. And I can see in here my leaks. I'm gonna start using the app like I would normally do. So I just come here, get back. I tap in here, I notice that it's taking some seconds to complete and then get back. And this is happening again and again. But right now, this is not showing me any leaks. So I'm gonna try to see if I can find something. So no image in here. This is funny. So apparently there are no memory leaks in this example, Honza.
Impossible.
Let me let me check.
Oh yeah, because the example 2 is the leak.
Yeah.
Not the example 3.
Yes.
So you need to comment out everything that is example 1 and everything that is example 2. Have there. Yes, exactly. And if you just search for example 3 and example 1, it will get much easier.
Example 2. So
also comment out the thing above, the first photo manager. Yep.
Example 1. This one is no good, but this one is. And the photo manager is not in scope. Where's my photo manager? This shouldn't be here. This shouldn't be here either.
I can also send you the project with commented out all the stuff that needs to be commented out and commented in all the stuff that needs to be in. That is also possible.
I think this time I have it.
Nice.
So again, this time we should see leaks.
Let's hope for a leak. Nice. This is
Thank
actually
God
like
we have a leak. This is actually like the first time I'm happy to see a leak.
But this is actually a great example. Like this was a perfect demonstration of the leaks instrument not detecting the actual like normal retain cycles, right? Because we ran the leaks instrument on the example that doesn't have the orphaned leak. This is actually a good example.
The past example, right? This is what you were talking. Okay, so the leaks instrument, again, you have different options in here, and the stack trace in here is different as well. You can see the leaks at the roots and the call tree. I'm just going to choose to seek the leaks in here. And out of all of the things that I see here, for example, this one is familiar for me and this one is familiar for me. Of course, I've been working in this project, so I should know, but the same thing will happen to you guys in your projects when checking your memory, right? So I can see here that there's something going on with my photo manager, right? Because I have many instances. These are orphan. They are in there, right? But there's they have a strong references to themselves in this example. Okay, so I can see here, for example, that I have my code detail view controller, photo manager, and my photo manager, right? So when you guys see this stack trace in here, well, what you might want to do is to go there and check what is going on. So now we know the problem is in the photo manager because we see it in here, right? Now, what can be wrong inside this function? And now, I don't know if you guys remember when I said that you can break strong references between instances with by using weak or unowned reserved keywords, right? So, and you might want to do that, or you actually want to do that when you have closures, right? So if we check our photo manager inside our whole app, I see that I'm using it in my code detail view controller, which makes sense, and that I have my photo manager. So what is actually going on in here is I have my photo manager instance, correct? This is just a property. I get the instance, I assign it to this property, okay? So there is our strong reference. And then when this view controller disappears, when the detail view controller disappears, when I pop it back, I'm setting this to nil. Now, so far so good, right? But what happens on the other side? That I'm capturing the value itself. Why? Because I'm using this closure. So what you might want to do is just adding a capture list of weak self or unowned self, depending on the case. But weak will be okay for now. So aim small changes. Hit Command I so I can come here again, start a new session, check the leaks again. So basically do what I did before. And hopefully we won't have any leaks anymore. And yep, we don't have leaks anymore in this app. So, so that's about it for my presentation. Just to wrap things up, use it whenever it suits you. Use it whenever you finish a feature. At first it's overwhelming, but if you guys use it regularly enough, you'll get the grasp of it. Sorry about this small thing that happened with the code, but I hope you guys learned something. And if you have any questions, I'll be happy to answer.
So we have two more questions, if I'm seeing it correctly, one from YouTube and one from here on Zoom. The first one is it viable to create UI tests to go through specific flows within the application and then extract the profiling results so that they can be compared over time?
I don't know if I understood the question well, but I don't know how would you correlate the UI test, right? Because you will be testing inside a machine or a simulator, right? And then the profiling thing. I honestly don't see the relation. Maybe you, Hansa, you can help me with this one.
I think you can profile a UI test, although I've never seen it to be very popular. But there is a interesting development where I believe in XCode 12 there are some extensions to XCTest where you can actually measure things, like for example for animations like duration and stuff. So maybe it would make sense to use those things, but I've never really seen people automating the profiling as much. Although I've seen, I think, Peter Steinberger writing on his BSPDF blog an article about this. I don't remember the results exactly, but it's just not very common. That's for sure. Maybe we can send a link to the blog post in the email that we will be sending after this talk finishes. But yeah, it doesn't seem to be too common. And then there's a second question, and quite related, I'd say. Is there any way to automate checking on instruments results? I mean, to integrate it into CI via Fastlane or any other tool, or do we always need to do it visually?
I've never done it, honestly, and I never heard of this. And this is because you do this randomly, right? Whenever you feel like it, right? Whenever you see your app is slow, whenever you want to boost performance. So to be honest, I don't know, but that's something to investigate for sure.
I haven't seen it done either. It's a great question though. Although I can't imagine from the top of my head right now like how I would do it, because typically when I use instruments, I'm focusing on a specific thing, right? You're trying to find out something that that is quite specific. So I'm not sure. I'm not sure. I've never seen anyone do it, but maybe yes. It just doesn't seem to be very common. And there's one more question. Kubila is asking a follow-up to his previous question. He's saying it didn't seem to be very convenient to me to just click around the app in order to get some profiling results. So I'd rather look for ways to automate it. And yeah, that makes sense. Like ideally, in a perfect ideal world, your application actually has UI tests, and then you can profile those, right? So if your app is in a perfect shape and you have the budget for UI testing, then yes, it's much easier and much better, I'm sure. So if there are no further questions, I will show my face because I just realized that I'm not doing that. And Sebastian, thank you so much for the talk, even though there were, oh no, hold on. There is one more question from YouTube. Someone is saying, I think you can write your own dtrace script to use it on your CI environment. Oh yeah, if you want to go as deep, then for sure.
Sure. Yeah, if you want to do that.
And that's definitely an option. Although I wouldn't call it common either. At least not on a typical project in a smallish team. Anyways, Sebastian, thank you. Even though there were a few technical hiccups, I'm super happy that we ironed them out, and we're not even over time. So I think that it was a success, and I think that we have learned a lot of new stuff about instruments. Thank you so much.
Okay, thank you all, and thanks for the patience. And I hope again that you guys have learned something. Thank you. Bye.
Okay, thank you very much again. If there are no questions at all, I think that's it. Thank you very much, Sebastian. It was really nice, even though these technical issues occurred. I can see that there's thanks for the great presentation. It was very fruitful in the chat. So I think also the attendees appreciate it. Okay, so that's it from us. We are planning new iOS talks for next year as well. And the nearest one is from Jan Carlton, who will be presenting on 14th of January. So if you don't want to miss that, just check out our Eventbrite page or web event section in our websites, and you can register already there and make sure to don't miss it. If you want to promote it, Honza, one more time, here's your chance.
We can, for sure. I'll be speaking about porting iOS apps to Catalyst. So it is something that I believe that not many people do, but many people should do. So let's talk about it and see how easy it actually is.
Thank you. And since we want to be proud of everything we are doing, we would really appreciate your feedback to this event. So you should be able to see it once you close your Zoom, or I can share the link to the chat right now. So you should be able to see there as well. So thank you very much in advance, and hope you enjoyed it, and have a nice evening. Bye-bye.
Have a nice evening, everyone. Goodbye.